Well, here is the final of our four topics in the algebraic review that leads into the chapter on similarity. And this does carry us very close to similarity. The topic here is ratio and proportions. And the reason that this is so important for us in our study of similarity is we'll find that when we have similar polygons, that means that angles are equal, but sides are proportional. So very often we'll get proportions that we have to solve. So let us talk about ratios and proportions. And you'll find that the work that we did in the previous sections of algebraic review will be useful here because we'll have to solve quadratics and we'll have to simplify the radical expressions of results. So yeah, this is sort of the culmination of everything that we've done so far. So first of all, simply ratio defined. The ratio of A to B, where A and B, of course, quantities, denoted either as A fraction bar B or A colon B, is the number of times that B goes into A. That's just definition. So for instance, if we have, and why not, 12 armadillos and 4 possums, the ratio of armadillos to possums is 12 to 4. And of course, 12 to 4, 12 over 4 is also equal to 3 over 1, which means that for every possum, we have 3 armadillos. Proportion. A proportion is simply an equation of ratios, like the one that you see. You have an equation, because of course you have the equal sign. On the right-hand side, you have a ratio. On the left-hand side, you have a ratio. So that makes a proportion. We can also write a proportion as A colon B double colon C colon D. That's sort of the traditional way to do it, and I'll sometimes write them like that. And that is often read as A is to B as C is to D. But that can always be translated into what is perhaps the more familiar form with the equal sign and the fraction bar. A little bit of terminology that will be important to us when we begin in the next section to prove geometrical theorems. In the proportion A colon B double colon C colon D, that is A over B is equal to C over D, the B and the C are called the means, and the A and the D are called the extremes. And if we were to write this in that fraction form, what that means is that the extremes are, first of all, the top of the first ratio, and then the bottom of the second ratio. And the means are first the bottom of the first ratio and the top of the second. Now, we won't actually use that language much in this first section, but later on we certainly will. There'll be certain geometrical theorems that will be expressed in terms of means and extremes. Now, how do we solve a proportion? Well, here's a little result that I'll actually have you prove on the worksheet. If a proportion is true, then the product of its means is equal to the product of its extremes. So as you see in symbols, if A over B is equal to C over D, then A times D, that's the product of the extremes, is equal to B times C, which is product of the means. Now, in your algebra classes, you probably heard this expressed in a different way. You were probably, uh, the language used there was probably cross multiplication. And it's the same idea. So what I simply tell you here that you can do is you can cross multiply and get A over D is equal to B over C. And so then you would be able to solve proportions like this. Let's say that we had x minus 3 over 3 is equal to 5 over 4x. Well, what do? Um, we form the product of the extremes, which is 4x times x minus 3, is equal to the product of the means, which is equal to 3 times 5. And then let's see, what does that become? Well, the distribution on the left-hand side gives us 4x squared minus 12x is equal to 15. And well, would you look at that? That's a quadratic. This will happen very, very often to us. And it won't happen because I force it to happen. Rather, it arises very naturally in the study of similarity. Okay, so we have 4x squared minus 12 x, let me sneak that in, is equal to 15. And you remember how to solve these, right? I'll just get you set up on this. We would write this quadratic in standard form. So it's 4x squared minus 12x minus, oops, for some reason, I don't want to have that x there. I should have that x there. So minus 12x, subtract a 15 from both sides. So minus 15 is equal to 0. Then you remember what we did, right? That means that A is equal to 4, and B is equal to negative 12, and C is equal to negative 15. And then I tell you what, here's a little test for you. You could pause the presentation here, the video here, and actually try it out yourself. But what you should end up with for the possible values of x are 3 plus or minus 2 times the square root of 6. Don't know why it does that. 2 times the square root of 6 over 2. That's what you should get. And along the way, you're going to get this expression under the radical, root 384, so you'll have to simplify that expression. Just pause here, see if you can actually do that work and get to the final answer, 3 plus or minus 2 square root of 6 over 2. Now, in just a moment, I'll introduce a tool to you, an online tool that will allow you to get the answers to these immediately. I'll still expect you to show me the work, but you can use it to check your work very easily. Okay, now the converse. You remember what converses are, of course, right? Converses are where you have a conditional and then you switch the order of the two parts. So before we had, if you have a true proportion, then the product of the means is equal to the product of the extremes. Well, the reverse of that is true as well. So if the product of the means is equal to the product of the extremes, then that proportion is true. That is, if AD is equal to BC, then A over B is equal to C over D. And that gives us a way to verify that proportions are actually true, that they're actually correct. So consider the first one. 17 over 58 is equal to 153 over 522. Perhaps we should put a question mark over that because we want to know whether this is actually true. Well, how do we verify? Well, we ask ourselves whether 17 times 522 is equal to 58 times 153. Now, I won't take the time to actually multiply this out with you, but that's the question, okay? That equation can be easily verified, with a calculator or online, and if it's true, then the original proportion is true. And if it's false, the original proportion is false. Now, I won't take the time to do the second one as well, but you can do it in exactly the same way. Simply multiply the extremes, that is the 1.23 and the 10.12, multiply the means, that is the 4.56 and the 2.87, and just determine, just by inspection, whether they are equal values or not. If they are equal, then the proportion is true. If they're not, then it's not. So that is just about it. But let me mention one resource to you. It's called Wolfram Alpha. You can do a quick Google search for that. Now, for the homework assignment, I won't provide answers to you in the solutions file for the most part because I simply don't need to. You can verify your answers at Wolfram Alpha. It's an incredibly powerful tool. So you can go to Wolfram Alpha, and up at the top, you'll see an input bar, very much like the familiar Google search bar. But it's a kind of search, as it were, for equations. It will search out solutions. It will do much other mathematics as well. So you could simply type in 4x, that's the caret symbol too. That's how Wolfram Alpha does exponentiation. So 4x caret 2 minus 12x minus 15 equals 0, just hit return. And it will show you lots. It will show you a graph. Don't know exactly what else it shows you, but it will show you the solutions as well, not expressed merely as approximations, but an exact simplified form as well. So I will expect you to go to Wolfram Alpha to verify your answers. Do not take this as an opportunity to simply skip all of the work. Of course, on a test, I would expect you to be able to do that work and do it correctly and simplify the result, which involves the radical simplification skills that we've seen before. But do know that you can verify your answers there. All right, and then that's it. We're done with algebraic review. And next, we will move on to actual geometry, and I will introduce to you the precise definition of similarity, and then we'll begin to prove theorems.